Hello everyone, let's begin the integration. In this video, we'll be dealing with the indefinite integration as well as the definite integration. Integration is a very important part of the calculus. So you can take out your notebook and pen and start making your notes. As usual, in between the video, you'll get few checkpoints for your practice, and answers of all those checkpoint questions can be verified at the end of this video. So let's start. If someone asks you what is the meaning of the term integration, your simple answer should be addition or summation. The addition can be done using various mathematical operators. One of them is this Greek letter sigma. The sigma is used for the addition of the discrete values. For example, 1 plus 2 plus 3 up to 10. Let's say we want to sum up. Then this will be represented as summation or sigma I is equal to 1 to 10. Getting it? So you can note it down. For summation of the discrete values, we use the operator sigma. Okay, sometime we need to sum up the continuous values or the continuous functions. That can be done using the definite integration. Let's learn it through an example. This is x-axis, this is y-axis. Suppose we have a random curve and its equation is given as y is equal to fx. Let's say this coordinate here on the x-axis is a and this coordinate here on the x-axis is b. We want to find this area bounded with the x-axis. Can you think how to obtain this area? If I ask you the area of triangle, rectangle, square, trapezium, you know the formulas. But this area is a bit different. It can be obtained using the integration. How? Let's pay attention. Suppose you take an elemental strip of width dx here. Actually, this dx width is infinitely small. So you can imagine this to be a rectangle. This small rectangle has the area, let's say, dA. Now, if you can break up this entire area into such small rectangles and you find the area of each rectangle and then sum them up, you will get the total area. Getting my point? The small elemental area of this strip can be written as length into breadth. The length of this rectangle will be the fx and the width of this rectangle is dx. So this is the small elemental area. But we wanted the complete area A, and for complete area we will be summing up all such elemental areas. And that will be shown here as A. So A will be basically integration dA. Lower limit is small a and upper limit is small b. And here also you should show it as from small a to small b. Getting my point? Area of this curve is a continuous function. So we are using the integration. You'll understand it in next few minutes very well. You can write up to here and then we'll talk about the notation of the integration in detail. Let's see the notation of the integration. Suppose somewhere you see such kind of illustration, then you should always think about the integration. This is the sign of integration. Wherever you need to do the integration, you'll find this sign. Okay. Let's say you find few numbers also here. This is A, this is B. Then this A is known as the lower limit. This B is known as the upper limit. This fx is known as the integrand, the function whose integration you are going to do. And this x is the variable of integration. Fine. Suppose somewhere you see this kind of notation. what you will understand? Post your answer in comment box. Looking at this, what you get in your mind? Actually nothing. This is of no use, because whenever you do the integration, the variable of integration must get defined there. Without the variable of integration, you cannot integrate. So this is useless. Correct representation would be, let's say if someone gives you the things like this, here you have defined the variable of the integration. So this representation is good one and this one is wrong. Getting my point? Basically, this sign is a mathematical operators. We have already read few mathematical operators, if you remember: addition, subtraction, multiplication, division and differentiation in the previous video. And our focus in this video will be on the integration. There is one interesting relation in between the differentiation and integration. They are inverse operators of each other. What do we mean by the inverse operators? In mathematics, for every operation, there is inverse operation defined, such as for addition, the inverse operation is subtraction. For multiplication, the inverse operation is division or vice versa. Similarly, the integration is the inverse operation of the differentiation. Getting it? Note down and then you'll get a checkpoint. In that checkpoint, you have to figure out yourself that which things are the continuous and which examples are the discrete one. Okay? As we were talking that the integration and differentiations are the inverse operations, so let's relate them. Here I'll be writing the formulas of differentiation, and here we'll be writing the formulas of the indefinite integration. Suppose someone says you to differentiate the constant c, then what is your answer? You remember that? Differentiation of any constant is 0, because differentiation gives you the rate of change, and if something is constant, its rate of change is 0. Now, if you integrate this 0, your answer will be a constant. You'll understand it. I am taking few more examples. Suppose you differentiate this x plus c, then differentiation of x with respect to x will be 1. And differentiation at that constant will become 0. Now you integrate this 1 with respect to x. Then your answer will come out to be x plus c. Okay, taking another example. What should be the answer here? Differentiation of r with respect to r is 1. And differentiation of c is a constant, its differentiation is 0. If you integrate this 1 with respect to the variable r, then your answer will be r plus c. Okay, taking another example, let's say you have d by d theta of theta plus c. What should be the answer? 1 again. And if you integrate this 1 with respect to the variable theta, then your answer will come out to be theta plus c. I hope you get it. Another example, let's say we differentiate the sin x. The differentiation of sin x, you know, is equal to cos x, and differentiation of c is 0. Now, if you integrate this cos x with respect to the variable x, then your answer will come out to be sin x plus c. Pretty interesting operation. You can relate them very well. Suppose we differentiate the e to power x plus c. You know the answer. It will be e to power x. Now, if you integrate this e to power x with respect to the variable x, then your answer will be e to power x plus c. In this way, we can relate the differentiation and the indefinite integration. Okay. On the next screen, I'll be relating all the formulas of the differentiation as well as the indefinite integration. So you should note down up to here and then we'll go to the formula table. Here you can see all the formulas of the differentiation on the left hand side and all the formulas of the indefinite integration on the right hand side. Pause the video here and note down very carefully, because if you remember all these formulas, if you learn all these formulas, then entire remaining video will be a piece of cake for you. All the calculations will become super easy for you. Okay, so note them down. Now we'll be taking up few examples based on all these formulas. So let's initiate. I'm starting with example number 1. Suppose somewhere you find this integration dx. How to operate it? This can be written as 1 multiplied with dx, because multiplication of 1 with anything won't hamper the calculation. And the 1 is actually equivalent to x to power 0. So we can write this as x to power 0 here. Fine. What is the advantage of doing that thing? You remember this formula, integration of x to power n with respect to the variable x. The answer was x to power n plus 1 divided by n plus 1 plus some constant c. Using this, we can simplify the things. X to power n, we can compare. So the answer will be equal to what? X to power 0 plus 1 divided by 0 plus 1 plus c. And this can be simply written as x plus c. I hope you get it. Now, the same illustration can be asked in a different manner. Example number 2. Suppose someone asks you integration d theta. Then can you tell the answer comparing with this? It's pretty simple. You can easily tell that answer will be equal to theta plus some constant c. Same example can be asked like as, then what should be your answer? Write it in the comment box. It will be equal to t plus c. Okay. Example number 4. If someone gives you integration dr, then your answer will be r plus c. I hope you get this. Fine. Taking up another example here. Example number 5. Let's say you have to operate this x to power minus 1 by 5. Same formula you have to use. Give it a try and post your answer in comment box. I'm doing the calculations here. It will be x to power minus 1 by 5 plus 1 divided by minus 1 by 5 plus 1 plus some constant c. I hope you get this. If you wish, you can simplify it further. It will be x to power 4 by 5 divided by 4 by 5 plus c. So final answer is, okay, note it down. Then we'll be taking up few more examples. Let's take up the next example. It's based on the same formula. This can be written as x to power 1 by 2. And then using the formula, we'll get the immediate answers. So we should write the answer as x to power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus some constant c. We can simplify it further. X to power 3 by 2 divided by 3 by 2 plus the constant c. And it will look like as 2 by 3 x to power 3 by 2 plus constant c. Clear? Taking up example number 7 then. Suppose someone asks us to integrate the 1 by root x with respect to the variable x. Pause the video here and try to post your answer in comment box. I'll be solving it here only. this can be written as x to power minus 1 by 2. I hope you understand this thing. And then we can easily utilize the formula. So I should write here x to power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 plus some constant c. Let's simplify it further. It is x to power 1 by 2 divided by 1 by 2 plus c. So your final answer will be 2 root x plus c. I hope you understand this thing. It's pretty simple. If we remember this formula, we can solve as many questions as we wish. I'm taking up example number 8 here only. Suppose someone gives us x to power 5. Now can you post your answer in comment box? Simple. The answer will be x to power 5 plus 1 divided by 5 plus 1 plus some constant c. So it will be x to power 6 divided by 6 plus c. Okay. And the same question can be asked for other variables also, r, t, p, z, anything. Such as, I'll take one example here. Example number 9. If someone asks us how much is the integration of t square with respect to the variable t, then using this formula only you can get the answer. Instead of the variable x, now we have the variable as t. So same format can be used. You can think this as t to power n dt. Then answer will be t to power n plus 1 divided by n plus 1 plus some constant c. Now post your answer. T cube by 3 plus some constant c. I hope you understand how you get this answer. Okay, note it down and then we'll be taking up example number 10. Here is the example number 10. We have to simplify this. Do you remember any formula for this? Integration of sine ax plus b, and the integration is done with respect to the variable x. Then what was the answer? It was equivalent to minus 1 by a cos of ax plus b plus some constant c. I hope you remember this. If you remember this formula, then the computation will be pretty easy for us. I'm doing the calculations. Let us compare it with the format ax plus b. So this is a, this is x, and the b here is 0. So what should be your answer? Minus 1 by a. A is 2. Cos of ax plus b. Ax, b is 0. No need of writing that. Plus some arbitrary constant c. Okay. Taking up example number 11. Now try it using this formula. It's pretty simple. The answer should be minus 1 by a, this is a, cos of ax plus b, so 2x plus 5, and the constant c. Clear? Next example, example number 12. See, if you remember the formulas, you can solve numerous examples very easily. Suppose someone is asking you sine x by 2, you have to integrate with respect to the variable x. Give it a try. It's simple thing actually. You can think it of as you have to simplify a x plus b, where a is 1 by 2, x is x only, and the b is 0. Now you can easily compare the things. What should be your answer? Okay, so if you know the formula, you can simplify anything. Note it down, then we'll be taking up example number 13. You can see the next example on the screen. Pause it and then check the formulas, what you have written for such a question. Definitely you will get some formula in your notebook. Try it and then post your answer in the comment box. I'm solving it here. In your formula table, you might have seen this thing. This is ax plus b to power n, where a is 1, b is 2 and n is 5. We have to just submit the values. So it will be 1 by 1 x plus 2 power 5 plus 1 divided by 5 plus 1 plus some constant c, and we can simplify it further. X plus 2 power 6 divided by 6 plus c. That should be our answer. Okay, taking up example number 14. Same kind of integration but in a little bit different way. Let's say 3 theta plus 2 d theta, and here power is 7. Compare it with the given format. Instead of the variable x, here the variable is theta, but you can use the formula again. Actually, this is serving as a, this is serving as x, this is serving as b, this is serving as n. Ax plus b to power n kind of format is there. We can use that formula. So I am putting up the values. 1 by a is 3, then 3 theta plus 2 power 7 plus 1 divided by 7 plus 1 plus some constant c. Let us simplify it further. 3 theta plus 2 power 8 divided by 24 plus c. Done? Okay, you can note it down. Then we'll see few important rules related to the integration. Let's check the rule number 1, the constant multiplication rule. It's similar to what we have seen in the differentiation. Suppose you have some constant which is in multiplication. Let's say k is in multiplication and k is a constant. Then how you operate such an integration? For that, the constant k is taken outside of the integration. So you operate it like this: k integration of fx with respect to the variable x. Getting it? It's pretty simple rule. If some constant is in multiplication with the function, you take that constant outside of the integration. I'm taking one example. We have the integration like this: 5 secant x tan x, and the variable of integration is x. Now 5 is a constant which is in multiplication, so it should be taken outside of the integration. You will rewrite this as 5 secant x tan x dx with the integration sign. Now, do you remember any direct answer of this? Check your formula table. The answer will come out to be secant x for this calculation, and there will be some constant c because we are dealing with the indefinite integration. Another example number 2, integration 3 cos 2 theta plus 7 d theta. Pause here and give it a try yourself. 3 is a constant, so you can take it outside of the integration. Then you are left with cos 2 theta plus 7, and the variable of the integration this time is theta. You remember any formula for this? Check your formula table. The answer will come out to be 1 by a sine 2 theta plus 7, and there will be some constant c. Clear to everyone? Note it down. Then we'll be taking up example number 3. You have to integrate a sine omega t plus phi with respect to the variable t. Pause here and give it a try. Here a, omega and phi, they are constant. Only variable is t. Let's simplify this. A is a constant and constant is in multiplication with the function, so I am taking it outside of the integration. So we are left with A integration sine omega t plus phi with respect to t. Okay, any direct formula for this? Check your formula table. It will be written as, I hope you get this. If you wish, you can simplify it further. So the major thing is this: we should be learning that formula table by heart, because in every question we'll be requiring the formulas only. Note it down, then we'll take up rule number 2, the addition subtraction rule. Let's talk about rule number 2. The addition subtraction rule, it's similar to what we have seen in the differentiation also. If you have such an integration fx plus minus gx, then you can individually operate them. If you have 3, 4, 5 functions in addition or subtraction, you can operate them individually. Let's take an example. You'll get it very easily. Example number 1, integration of x square minus 2x plus 5 with respect to the variable x. Here we have 3 things, so we can operate them individually. Now here we can use the constant multiplication rule. Constant can be taken outside of the integration. So this will be written as minus 2 I am taking outside, 5 also I have taken outside. Do you agree? Now let us simplify them. Integration of x square with respect to the variable x. I hope you people remember that formula. What was the answer? X to power n plus 1 divided by n plus 1 plus some constant c. Utilizing that, here we should be writing x to power 2 plus 1 divided by 2 plus 1 plus some constant c1. Okay. Now operating this, you can imagine as x to power 1, and then you can utilize the formula again. Minus 2 lies here outside, and then operating this thing. It will be x to power 1 plus 1 divided by 1 plus 1 and some constant c2. Fine. And here you can think of 1, and that 1 can be written as x to power 0. So basically here you have to integrate the x to power 0. So simplifying this integration here, it will be x to power 0 plus 1 divided by 0 plus 1 plus some constant c3. Do you agree? This 1 can be written as x to power 0, and then for integration of x to power 0 we have used the formula. Now these 3 constants c1, c2, c3 can be collectively written as a single constant to make the calculation easy. So I am writing the final answer: x square by 2 minus 2x square by 2 again plus 5x, and then you are left with c1 minus 2c2 plus 5c3. This entire thing is actually a constant, so you can write it as a single constant. Simplifying it further, x square by 2 minus x square plus 5x, and this is a single constant c. So next time onwards, if you have functions like these, instead of writing the individual constants at the last line of your answer, you can put only a single constant. Fine. Note it down. I'll be taking up 2 more good examples. It's a brilliant question. You have to integrate the sine square function with respect to the variable x. You can pause and you can give it a try. I'm solving it on board. We do not have any direct formula for such integration, so we'll be utilizing little bit of trigonometry. The sine square x from trigonometry can be written as 1 minus cos 2x divided by 2. Do you remember? I'm doing the replacement, so this question will actually look like as 1 minus cos 2x divided by 2, and you have to integrate it with respect to the variable x. Now we can easily use the addition subtraction rule. Writing this again, integration this 1 by 2 dx minus 1 by 2 cos 2x dx. Do you agree? This 1 by 2 is also a constant. It can be taken outside. So 1 by 2. This 1 by 2 I have already taken outside of the integration. Okay. Now we have to simplify these things. Integration dx. What will be its answer? You might remember its answer will come out to be x plus some constant c1 minus 1 by 2 outside, integration of cos ax plus b. The answer will be equal to 1 by a. A is 2 sine of ax plus b. B part is 0 plus some constant c2. Do you agree? Simplifying it further, x by 2 plus c1 by 2 minus 1 by 4 sine 2x minus c2 by 2. Okay, this c1 by 2 and minus c2 by 2 is actually a constant. You can club them and you can write a single constant. So your ultimate answer will be x by 2 minus sine 2x by 4 plus some constant. This answer is pretty important. I request you to learn it. Here is example number 3, identical to the previous question. You can pause and you can give it a try. This is also important one. We do not have any direct formula for the integration of the cos square function. So again, we'll be taking the help from trigonometry. The cos square x in trigonometry is written as 1 plus cos 2x by 2. Check the trigonometry video, you'll get it there. So this can be written as 1 plus cos 2x by 2. Now the calculation is simple for us. Do you agree? Now the 1 by 2 is a constant, so it can be taken outside of the integration. So here we are left with this thing, and here you are left with cos 2x. Okay, now you remember all the formulas. So utilizing the formulas here, this will be x plus some constant c1, this 1 by 2 outside, and this integration you can compare with this formula here. So the answer should be 1 by a. A is 2 sine of ax plus b. Ax b part is 0 plus some constant c2. Okay, simplifying it further, it is x by 2 plus c1 by 2 plus 1 by 4 sine 2x plus c2 by 2. Okay, going further, x by 2 plus sine 2x divided by 4 plus c1 by 2 and c2 by 2. this can collectively be written as a constant. So instead of C1 by 2 and C2 by 2, I am writing C. Clear? This is also very important. Note it down, and I request you to practice these questions once again yourself for better understanding. Then you'll be getting a checkpoint. You should pause there and try all those questions. Okay? Our next topic is the integration by substitution. Sometimes we have few questions in which we do not see any application of direct formula. Then we substitute something, we differentiate that thing, and then we rewrite the question, and question becomes bit easy. Let's see few example, you'll get it in a better way. Suppose someone asks you integration of root 1 plus y square 2y with respect to the variable y. Now look at this question carefully. Do you see any application of direct formula? It's not visible. It means it will be done with the integration by substitution. Okay. For substitution, we should choose the data wisely. This 1 plus y square, I'm assuming as p. Pay attention. Let 1 plus y square is equal to p. Now differentiate both sides with respect to p. It's pretty important step. Okay. So here what you will have, d by dp of 1 plus y square is equal to d by dp of p. Do you agree? Now simplifying this further, it will be d by dp of 1 plus d by dp of y square is equal to d by dp of p. You know the answer. It will become 1. Differentiation of 1 will become 0, as 1 is a constant quantity, and this differentiation will be solved using the outside inside rule. The power here is the outside function and this y is the inside function. So first of all, we'll differentiate the power and then we'll differentiate the inside function. Differentiation of power, we people know, 2y to power 2 minus 1 into d by dp of inside function, and your inside function was y, is equal to 1. Do you agree? Now here we have 2y dy and dp I am shifting there. Look at this thing very carefully. Is it of some use to us? See here, this 2y dy can be written as dp and this 1 plus y square can be written as p. Now the entire calculation will become very simple. So I am submitting the values. Here we are left with root p and this 2y dy can be written as dp. This can be easily simplified as we remember the formulas. You remember integration of x to power n with respect to x. What was the answer? X to power n plus 1 by n plus 1 plus some constant c. Now instead of the variable x, here we have the variable p. Similar formula is applicable. So I am writing the answer. This will be p to power half plus 1 divided by half plus 1 plus some arbitrary constant c. It is p to power 3 by 2 divided by 3 by 2 plus some constant c. Now value of p is known to us. So I am writing the final answer 2 by 3. At the location of p, I am writing 1 plus y square power 3 by 2 plus some constant c. This is the final answer. Getting it? These questions are pretty simple. In the given question, you assume some quantity as p, then differentiate that quantity. You will get some useful substitution and then question will become pretty easy. Okay, note it down. We'll take 2 more questions. Taking up the next question, suppose we have the integration x square sine x cube and the variable of the integration is x. Pause the video here and you give it a try yourself. It is a question of integration by substitution. I am solving the things here. Let the x cube is equal to p. Because when you differentiate this x cube, you will get 3x square, and that x square is useful in our calculation. That's why we have chosen this function. Now we have to differentiate both sides with respect to p. Okay, so I should write here d by dp of x cube is equal to d by dp of p. This LHS will be solved using the outside inside rule. The power here is the outside function and this x is your inside function. So first of all, we'll differentiate the power. So it will be 3x to power 3 minus 1 into d by dp of inside function, and inside function was x. Do you get this? Is equal to d by dp of p. Everyone knows the answer will be 1. So we are left here with x square dx is equal to dp by 3. Pay attention. And this is x square, this is dx. dp I have shifted to the RHS, as well as 3 also has been shifted to the RHS. Okay. See the advantage of this computation. Somewhere do we have x square dx in the question? Yes. Here we see the x square and dx. So I can do the replacement now. Question will appear a bit easy. Instead of x square dx, we can write 1 by 3 dp. Okay. And then sine of x cube. This x cube will be now written as p. Fine. 1 by 3 is a constant. Constant can be taken outside of the integration. So we are left with 1 by 3 integration of sine p dp. Fine. Now you remember the formula. Integration of sine x with respect to the variable x. What was the answer? Minus cos x plus some constant c. Similarly, this integration will result into what? Minus cos p plus some constant c. Okay. Now value of p is already known to us. So your answer will become minus 1 by 3 cos of x cube plus 1 by 3 c. Fine. This is your final answer. You can note it down. It's similar to the previous question only. Taking up the next question. Integration sine to power 4 t cos t dt. I again request you pause the video here and give it a try. It's a question of integration by substitution. What you should submit here as p. Let we take sine t as p. Now differentiate both sides with respect to p. So we should write here d by dp of sine t is equal to d by dp of p. Okay. This differentiation will be solved using the outside inside rule. This t is your inside function and this sine is your outside function. So first of all, we'll differentiate the outside function and then we'll differentiate the inside function. Differentiation of sine of something is cos of something into d by dp of the inside function, and your inside function was t. Okay, is equal to, in the RHS the value will be 1 because differentiation of p with respect to p is always 1. Now few things are useful for us if we look at this computation. Cos t dt, you keep it in LHS and shift the dp to the RHS. See, now the question will become pretty simple for us. This question can be rewritten as p2 power 4 because sine t was equal to p, and instead of cos t dt you can bring the dp. Entire computation is easy. We'll be using this formula again. Integration of x to power n with respect to x results into what? X to power n plus 1 by n plus 1 plus c. Okay. Here instead of the variable x we are having the variable p. So the answer will be what? p2 power 4 plus 1 divided by 4 plus 1 plus some arbitrary constant c. We should not bother about the value of this arbitrary constant c. Okay. Putting up the value of p again. So sine t to power 5 divided by 5 plus some constant c. This is your answer. I hope you understood the method. You have to assume something as p and then you have to differentiate that thing. You will get some useful parameter for the replacement in the question. Okay. For practice, I am giving you a checkpoint on the next screen. You should pause there and you should try few questions using the integration by substitution. Fine. Let's go further. Our next topic is the definite integration. For definite integration, we will always be getting a definite answer. It means the C will not appear in your final answer. This is the difference between the indefinite integration and the definite integration. In the indefinite integration, every answer carries some arbitrary constant C, while as the definite integration, as the name indicates, will have some definite answer. There will not be any arbitrary constant involved in the final answer. Okay. See how to simplify the things. Suppose somewhere you have such an integration. Lower limit is a and upper limit is b. In the definite integration, there will always be the limits. And on simplifying, let's say we get expression as this: lower limit a here and upper limit b here. Then it will be actually simplified as g of b minus g of a. First we put the upper limit at the place of x, then there is a negative sign, and then we put the lower limit at the place of x. I'll be taking up numerous examples, you'll understand it. Take up example number 1. Suppose you have to operate the integration 1 to 2 x dx, let's say. Simple question. Let us simplify the things. Integration of x with respect to the variable x. You might remember the answer. It comes out to be x square by 2. And the limits are from 1 to 2. Now how to simplify the limits? At the place of x, first of all, you will be putting up the upper limit. So at the place of x, I am going to submit this upper limit. Upper limit was 2. So this will be 2 square by 2. Then there is a negative sign in the formula. So put that negative sign here. Now at the place of x, you have to put the lower limit. The lower limit is 1. So it will become what? 1 square divided by 2. Do you agree? Okay. Final answer is 3 by 2. Here no constant will appear in the final answer. Getting it? Now this answer can be obtained by taking the area under the curve as shown in the diagram. If you take the area of this trapezium between this curve and the x-axis, then that area will also have the magnitude 3 by 2 units. You can check it yourself. Note it down. Then we'll be taking up the next example. Taking up example number 2. Integration 0 to pi by 2 radian sine theta d theta. I'm solving it, just pay attention. The integration of the sine function, we remember, comes out to be minus cos function. And if you wish, you can put that constant c. Right now I am telling you this c will ultimately get cancelled out. It won't appear in the final answer. That's why in the previous question we have not taken this constant c. The lower limit is 0 and the upper limit is pi by 2 radian. Now at the place of theta, first of all you will be putting up the upper limit. So how it will look like? Minus cos pi by 2 radian plus c. Then there is a negative sign in the formula itself. At the place of theta now you have to put the lower limit. So this will become minus cos 0 plus c. You can see one thing pretty clearly, that c here and this minus c will ultimately get cancelled out. They will not appear in the final answer. That's why to make the calculation simple, you can skip the c in the initial steps. Okay. Simplifying it further, cos pi by 2 radian, do you remember it's how much? It is 0. So writing the 0 here plus c, then there is minus, and this cos 0 will become 1 and minus sign in multiplication will become plus. So ultimately here you will have plus 1 and here you have minus c. The c is getting cancelled out. The final answer is 1. Clear? So next question onwards, I will not be writing that c because ultimately it will get cancelled out. And this answer can be obtained by taking the area bounded between the sine function and the theta axis. You can see the illustration here. From 0 to pi by 2, if you check the area bounded and you take the magnitude of that area, it will come out to be 1 unit. Okay, note it down. Then we'll take up example number 3. Taking up example number 3, lower limit is 0, upper limit is pi by 2 radian, and you have to simplify this. You can pause the video here and you can give it a try yourself. It's similar to the previous question. I'm solving the things here on the board. Integration of the cos function results into the sine function, and now I'm not writing that constant c because it will ultimately get cancelled out. The lower limit is 0 and the upper limit is pi by 2 radian. At the place of theta, first of all you will put up the upper limit. So it will become sine of pi by 2 radian. Then there is a negative sign due to the formula itself. Now at the place of theta, you will put the lower limit, which is 0. So it is sine 0. Okay. Sine pi by 2 radian, everyone knows, is 1. And sine 0 radian is 0. So your final answer is 1. Okay. This can be seen in the given curve. The area bounded by the cos function with the theta axis in the limit 0 to pi by 2 radian. If you check, that area will have the magnitude 1. Fine. Note it down. Then we'll be taking up example number 4. Here is the next question. You have to integrate the cos function in between the limits 0 to pi radian. You can pause the video and you can give it a try. I'm solving the things on board. We know that integration of the cos function will result into the sine function, and no need of writing that constant c because ultimately it will get cancelled out. The limits are from 0 to pi radian. Okay. Now at the place of theta, first of all we will be putting up the upper limit. So it will be sine pi radian. Then there is a minus sign because of the formula. Then at the place of theta, we will be putting up the lower limit. So it will be sine 0. Sine pi radian, everyone knows, is 0, as well as sine 0 radian is also 0. So ultimate answer will be 0. I hope you got that answer. And if you look at this diagram in the limit 0 to pi radian, then area above the theta axis is taken as positive and area below the theta axis has been taken as negative. So the total summation of the area will come out to be 0. Okay, note it down. Then we'll be taking up example number 5. Here is example number 5. You have to integrate the sine function in the limits 0 to pi radian. Pause here and give it a try. I'm solving the things on board. The integration of the sine function results into minus cosine function, and no need of writing that constant c because we are solving the definite integration. Lower limit is 0 and the upper limit is pi radian. Now put up the values. At the place of theta, first of all, you will put up the upper limit. So it will become minus cos pi radian. Then there is a negative sign because of the formula itself. Now at the place of theta, we need to put the lower limit. So it will be minus cos 0. Okay, let's put up the values. Cos pi radian, do you remember from trigonometry, is minus 1. So this minus and this minus 1. Finally here we will have 1. Then there is a negative sign. Minus cos 0. Cos 0 is always 1. So put here 1. So 1 and this will become plus 1. So answer will be 2. Okay. Now if you look into the diagram given on the board, in between the limit 0 to pi radian, the area bounded by the sine curve and the theta axis, the magnitude of that area will actually come out to be 2 unit. Okay, note it down. It's a nice question. Then we'll take up example number 6. Here is the example number 6. It's pretty important one, and I'll request you to learn its final answer because in many chapters of physics will be requiring such calculations. In order to solve this question, we should be remembering the integration of the sine function. I hope you remember the formula. Integration of the sine function with respect to the variable x. The answer was minus 1 by a cos of ax plus b plus some arbitrary constant c. Okay, let us utilize it. Here the a will be equal to 1. A is 1. At the location of x you have theta, and at the location of b you have phi. Okay with the comparison? Now I am putting up the answers. Minus 1 by a is 1. Cos of ax plus b, ax plus b means theta plus phi. Okay, and this has the limit 0 to 2 pi radian. Now at the place of theta, we will be putting up the limits. First of all, we'll put the upper limit. So I am putting the data here. Minus cos, the upper limit is 2 pi. And then there is a negative sign because of the formula. Now at the place of theta, we will be submitting the lower limit. Okay. So it will be minus cos 0 plus phi. Do you agree with this computation? Fine. Okay. Now cos 2 pi plus some angle. Do you remember the trigonometric ratios of the higher angles? Cos 2 pi radian plus some angle phi. The answer will be the same trigonometric function. So on this computation you will get minus cos phi, and this computation is resulting into plus cos phi. So the ultimate answer will come out to be 0. See, the interesting thing, your answer is independent of the value of phi. Whatever might be the value here, your answer will come out to be 0. Okay. Now you see the diagram on the screen. The area bounded in between the limits 0 to 2 pi radian, the equal area we have as positive as well as the equal amount of negative area. So the net summation of area will become 0. Okay, note it down. It's a good question. And then you'll be getting up checkpoint number 4. You can pause there and you can try to solve the questions. Our next topic is the area under the curve. Using the definite integration, we can find the area bounded between the curve and the given axis. Suppose this is x-axis and here we take the fx. We have a random curve. Equation of the curve is y is equal to a function of x. And we want to obtain this area A. The lower limit here is A and the upper limit is B. Our target is this much area. You might remember the starting of this video. We have done that. In order to obtain the area, you consider here a strip of width dx. This dx is actually very small width, and then this shape will look as a rectangle. The elemental area of this rectangle is given as dA, which will be equal to the length into breadth. The length is fx and the breadth is dx. Getting it? In order to obtain this complete area A, we need to integrate it. And the limit of integration will go from the lower limit A to the upper limit B. So here also you should integrate from A to B. Clear? I'll take a few examples, you'll understand it better. We have a parabola y is equal to x square and we need to obtain this area A. Do you know any direct formula for computation of this area? Because it's neither triangle, rectangle, trapezium. It's a bit different. In order to obtain this area A, we will be taking the help of the definite integration. See, the area A will be written as 1 to 2, lower limit is 1 and the upper limit is 2. The function is x square, you integrate it with respect to the variable x. Now the computation is pretty simple. Integration of x square, you people remember that, is x cube by 3. Lower limit is 1 and the upper limit is 2. Now at the place of x, put up the upper limit first. So this will be 2 cube by 3 and then there is a minus sign. Now you put the lower limit at the location of x. So it is 1 cube by 3. So 8 minus 1 by 3, your answer will come out to be 7 by 3 units. Okay, this blue area bounded between this parabolic curve and the x-axis will be equal to the 7 by 3 unit. Fine. Pause here and note it down. Then we'll take up the another example. Here is the next question. We have to find the area bounded between this curve and the x-axis for the limit x is equal to minus 2 to x is equal to plus 2. Calculation is pretty simple. We'll be using the definite integration. So the required area will be minus 2 to 2. The function is x square and we have to integrate it with respect to the variable x. We know how to compute this integration. It will be x cube by 3 and the limit is minus 2 to 2. At the place of x, first you will put the upper limit. So it will become 2 cube by 3. Okay. Then there is a minus sign due to the formula itself. Now at the place of x, you will put the lower limit. So minus 2 cube divided by 3. Do you agree? Let us simplify this thing. The area will come out to be 8 by 3 and this will also become minus 8 and another minus sign here, so it will become plus 8. So here also you have to write 8 by 3. So the final answer will come out to be 16 by 3 unit. Okay, pretty simple question. And if you see the diagram on the board, the area bounded between this curve and the x-axis in between these limits will be 16 by 3 unit only. Fine, note it down. Then we'll take up example number 3. Here is the example number 3. We have a cubic function and we have to find the area bounded by this cubic function with the x-axis in the limits x is equal to minus 2 to x is equal to plus 2. I hope you understand the question. You can pause the video here and you can give it a try yourself. I am solving it on the board. The question is pretty simple actually. To obtain the area, we'll take the help of the integration. The lower limit is minus 2 and the upper limit is plus 2. The given function is x cube and we have to integrate it with respect to the variable x. Let us simplify the things. Integration of x cube will give you x to power 4 divided by 4. The lower limit is minus 2 and the upper limit is plus 2. Now at the place of x, first of all we will put the upper limit. So it will become 2 to power 4 divided by 4. Then there is a negative sign in the formula itself. At the place of x, now we need to put the lower limit. So minus 2 to power 4 divided by 4. You can simplify it. It will come out to be 0. And you can see the diagram also on the board. The area above the x-axis is taken to be positive and the area below the x-axis has been taken as negative. So the positive and equal negative area will get nullified and the final answer will be 0. Okay. Now you'll be getting a checkpoint. You should pause there and you should try all the questions yourself. Our next topic is the area of the circle. Everyone knows the area of circle is pi r square if the radius of the circle is r. How to obtain it? I'll be obtaining the area of circle using two different methods. Pay attention, I'm taking the method number 1. Let's say we have a circle as given in the diagram. We cut the circle in 4 equal parts and then rearrange those parts. The shape is bit irregular. Next time we take up the same circle. Now we slice it into 8 equal parts. Now we arrange those 8 equal parts, but yet the shape is bit irregular. In the last diagram, we are cutting the circle in more number of parts and we are arranging them as shown in the diagram. Now the final diagram looks like as a rectangle and we know how to obtain the area of the rectangle. The length of this rectangle is pi r and the width of the rectangle is r. So the area of this rectangle will be pi r into r, which will become pi r square. It's an intuitive method. Now the area of circle I'll be obtaining using this onion and the integration. How? Pay attention. Suppose first of all we chop the onion half, then it will look like as shown in the diagram. Now on this chopped onion, can you see the concentric rings? How we will obtain the complete area of the circle? We will consider any ring as an element. We will cut that element, we will stretch that element, then it will appear as a rectangle and then we'll be finding the area of all such rectangles. I'm doing the calculation, pay attention. Suppose this is a circle. You go at a distance x from the center like as shown here and then you imagine a ring. This ring has the width, let's say dx. Okay. Now you cut this ring and stretch it out. then the ring will look like as a rectangle. The length of that ring will be 2 pi x and the width of the ring will be dx. We are talking about this elemental ring. This area we call as dA. How much is the dA? It will be length into breadth, so 2 pi x dx. We want the complete area, so for complete area we need to integrate the dA. And what will be the limit? The lower limit is 0 and the upper limit will be the r, because you can have a ring here, you can have a ring here, and the last possible ring will have the radius r. So the limit will go from 0 to capital R. Do you agree? Putting up the data, 2 pi x dx, limit is from 0 to r. Here 2 pi is constant, so I am taking it outside of the integration. We are left with x dx and limit is from 0 to r. What is the integration of x with respect to x? I hope you all remember. It comes out to be x square by 2 and the limits are from 0 to capital R. Okay. Now at the place of x, first of all we'll be putting up the upper limit. So simplifying the things, 2 pi at the place of x, I am bringing that r. So here is r square by 2. Then there is a negative sign. At the place of x, now we'll bring the lower limit. So 0 square by 2. Now we can simplify it. 2 and 2 is getting cancelled out and the final answer is pi r square. It's pretty interesting one. Okay, you can note down these methods. Using the integration, we can even find the volume, we can find the location of center of mass, we can find the moment of inertia. There are numerous applications. These all applications will come in the following lectures. Fine, note it down. Now we are into the last topic of this video, the average value of a continuous function in the given interval. You can see the formula for the average value. I'll be taking up example to illustrate this. Here is example number 1. Find the average value of the function y is equal to 2x plus 3 in the interval 0 to x less than equal to 1. This is the question. The solution part is pretty simple. We know that formula of the average value is equal to integration fx dx from the limit a to b divided by dx a to b. Do you agree? Now putting up the values, the function here is 2x plus 3. So lower limit is 0, upper limit is 1, function is 2x plus 3 divided by the dx and the limit is from 0 to 1. Okay. Now we need to simplify this thing. I am doing the calculation here. 2 is a constant, so I am taking it outside. 0 to 1 x dx. Do you agree? Plus 3 is a constant, taking it outside. 0 to 1 dx divided by this integration dx will result into x and the limit is from 0 to 1. Fine. Simplifying the things further, we have 2 here and integration of x with respect to x will give you x square by 2 and the lower limit is 0, upper limit is 1, plus we have 3 here and integration dx will result into x, limit is from 0 to 1, and here in the numerator you are left with 1 minus 0. Is it okay for everyone? Now simplifying the things further, here we have 2 at the place of x. First of all we will put the upper limit, then we will be putting up the lower limit. So it will become 1 by 2 minus 0 by 2 plus 3, 1 minus 0 divided by 1. No need of writing that. Let us simplify it further. 2 into 1 by 2, it will become 1, and plus 3 will make it 4. It means the average value of this function for this interval will be equal to 4. I hope you get this. It's pretty simple calculation. Pause the video here and give it a try yourself. Here is the last question of this video. There is a curve given between the speed and time, and we have to find the average speed in the time interval t is equal to 0 second to t is equal to 25 second. Okay, I'm simplifying the things here. You people might remember the formula of the average speed. The average speed is equal to the distance traveled divided by the time taken. Okay, and the distance traveled will be equal to this complete area. This area A will give you the distance traveled. You will read this thing in the chapter kinematics also. So how to find this much area? One way is the integration and the other way is simple. You can find the area of trapezium. I'm using the formula of area of trapezium, half sum of parallel sides. This is one side of the trapezium and this is the other side of the trapezium. I am summing them up. So this is 25 and this side is 10. 25 plus 10 into perpendicular distance between these two sides. The perpendicular distance between these two sides is 20 divided by the time taken in this journey. Total time taken in this journey is 25 seconds. Getting it? We can simplify it further. It will come out to be 350 divided by 25, and on simplifying that it will become 14 meter per second. Okay, this was the last question of this video. On the next screen you'll get the answers of all the checkpoints. Stay awesome. Take care.